Welcome to Front Project Monday. The project on Monday will relax. There are no deadlines, there are no managers. We built something really nice. Some very relaxed electronic project. We're going to talk about it. We're going to do everything. And to enjoy it really, take your favorite drink. I got coffee. I'm happy. I'm really happy. So we're still working on our LED controller, and for that LED controller we designed last week, or we started designing last week, our power stage. Let's take a look. Okay, so our goal was to get our input voltage converted down with a possibility of having of a 24 volts in. We convert the voltage for our LEDs down to 12 and 5 volts. That voltage comes out here. And we've got a switchable voltage divider to change our voltage from 12 volts to 5 volts. Okay, today I want to find out something. Because as I mentioned the last stream, in the newest version of DipTrace, we've got such a menu here where you get basic parts of JLC PCB. So I just wanted to see where to find them and what kind of parts we have. So this will obviously be some sort of small signal transistor. That's great. And I want to check, I wanted to simply taking a look on what kind of parts they do stock. So what I will change the browser window and simply go over and find out, because on the first glance they don't seem to have some higher amperage transistors, unfortunately, but we're going to see. To an 7.2, that's of course some very generic transistor MOSFET. Yeah, very small signal transistor, but okay. There we have an AO 3400A. I don't know this part too. Oh, that's an... I don't really. 30 volts, 6 ampere in an SOT 32. Okay. Yeah, indeed. Okay, that's a very high power device. That is... What kind of on-resistance does it have? Yeah, that's well 29 milliohms. That's relatively high, I would suppose. I read far better ratings on other transistors or on other MOSFETs. Although I think they would be way bigger, and they're cheap, really cheap. Okay, let's take a further look. And the A of, and that will be the equivalent in PNP, I suppose. Yeah, in P channel. Do we get a data sheet? Yeah, we will. We will get a data sheet. he will get an first RDA on. Yeah, about 10 milliohms more. And a maximum and not such a high continuous gate current. Okay, not such a high continuous current, but that would be in part that we could use for our project, because we need to do some high side switching, and that would be ideal because it has lots of because we would only need to switch 3 amperes and it's able to switch 4. That's great. And then we have an LBSS 84L. 84L. Did I write it correctly? Yeah, I did. What's that? Okay, another small signal transistor. Is it a P channel or an N channel? Oh, that should be an N channel. Okay. No, it looks okay. That's good to know. So I've taken a look on the transistors, then okay, some bipolar transistors too. And the MOSFETs and some bipolar transistors, oh my god. Okay. Sensor area motion. Sensors area motion sensors detectors. Okay. It's some kind of that was a category of standard parts. So we're interested on what kind of device that actually is. It's some kind of a okay, that's an expensive part. And that is an, let's check. It's an accelerometer. Okay, the Chinese build now accelerometers too. Okay. Or they would buy them in and rebrand them. Okay, then we have some resistor networks, some resistors. In dip trays we got, we'll have here some resistors in different sizes, from 04, 02 to 0805. We'll build our project completely in A085 because I have zero interest in soldering smaller than I have to. Because the first version will be definitely hand soldered, and no, I don't want to do this. How expensive are they? That would be good to know. How expensive are they? I don't know what kind of part do we have. We have an 0805, 0805, W, 8F, 27 JT5E, JT5E to get an ballpark. Yep, that's pretty cheap. Just to have an some kind of overview, one kind of voltage we have. Okay, we actually have different okay, what different packages come with different voltages, and most of them are 8 watts, 8 watts and 6 W8, V 1% resistance value. Okay. And of course all of them are LED free, otherwise you couldn't sell them at all. Some interesting things anymore. We have voltage regulators. Voltage references, you have display drivers, battery management, memory, 4000 series logic, and 555, Zener diodes. Fast diodes, size bridges, okay. Only one tantalum SND cap, okay. But I think they will be updated in the next version of DipTrace, so okay. Capacitors are a little bit better sorted, but okay. Okay, that's great. So, next we'll continue adding the LED driver, the LED driver transistors themselves. So we have some kind of connector. First of all, I will not assign any values or any kind of part number. I'll do this normally at the end. So we want to have symbols, and we want to have some kind of connector symbols. Yeah, some connector. Plug and suck. Yeah, that's great. So we have 3 outputs. Or let's do this directly as a wire, because most probably we'll do some sort of wire arrangement. And for an... Now I have to think in AW. Oh, that's easier. So we will add some wires. Of course we will have some very thin relatively thin wires. So let's take 21 gauge. 21 gauge is okay. With 21 gauge we can work pretty good. And we will add our different channels. So we have an LDR, LEDR. We'll have an LED blue. We have an LED red. Oh, I already got it. LED green, of course. LED G. And we will get an ground. LED plus 12 volts. Okay, now I will take a look on our previous solvents, because we will have, yes. And now we will add another LED 12 volts and 5 volts LED 3 plus. Because we will drive 12 volt and 5 volts LEDs. And one of these channels, or two, we will add a second function. LED R will also be ground. Just underscore ground. And LED B will be our data. We will leave G alone. Put that on the top because that's more of the convention. And that one will go on the bottom. So LED plus will be directly connected. Then LED data. LED data gets an... let's change that. We'll get an P-channel MOSFET. Although, because we have the parts and we most probably will use them. Wait a minute. I think I will directly use here the MOSFETs. So first of all, we got some N-channel MOSFETs for the different drivers. So we'll have LED red, we'll have LED green, and we'll have LED data. We maybe could get them a little bit cheaper, but if they are listed as, or at least pronounced as a standard part, we will use them, and makes things relatively easy. In theory, only one of these LEDs would, only one of them, or let me think, yeah. In theory, only the ground MOSFET would need to have a high current rating of 4 or 6 amperes, because the LED ground will act as a ground for a 5-volt LED supply, 5-volt digital LED supply. So this MOSFET needs to carry all the amperes if we only take if we don't use a distributed approach with an or digital approach. With the RGB LEDs, the ground gets distributed over all the MOSFETs, so we wouldn't need to think about it. Or you can only use 1 ampere MOSFETs, that would be pretty small. It would be okay. But here, at least the ground MOSFET needs to be relatively big, because all the current that flows through V plus will flow through will flow through LED R ground, therefore flow through LED MOSFET Q3, and that are 3 amperes. So we have plenty of space. So they all get connected to ground. Okay. So next we add the different nets. So now I will add some nets, so we don't have to put wires through all the PCB or through all the schematic. So I will simply name I will look how I named the other nets. Okay, I put the channel in the end, so I will say this is add to net. I'm going to see everything. LED blue. Connect with outer wire plus emitters. LED. LED B strich data. Oh, you would know it. LED. No, there's no better naming scheme. Data. Do it right with LED. Blue data. Channel 1. Okay, And we will do this with all the other ones. That will be the red ground channel 1. So, the next step, we would need to change the... that's good. The next step, we will add an N-channel or P-channel transistor to switch the voltage from the high side to the data line. For that, I will move that. I will move the components a little bit. I'll get some space. Oh. Come on. Oh, we'll simply use this one. I think we will change that later to find a more cost-effective part. And we'll add this. Or could be that using multiple of these ones will make could be cheaper than using a dedicated small signal MOSFET, because we get lots of quantities of these, and I think they wasn't that expensive. Let's compare this. Let's compare the prices. Let's check the difference. We want to check or compare A0 3400. We can get them for 3 cents a piece, and we'll compare them with the available 2N702. Put it directly down here, 2N702. And those we'll get for 2 cents a piece. In quantity, we'll get down to 2 cents also, depending on the supplier. So, doesn't make a big difference. If you consider that we will get less space on our, if we want to produce them. That's always an option. If there's interest in people buying such a project, I wouldn't bother changing the MOSFET for 1 cent, because then we have more. Because then we don't add cost to different. So we don't have a problem that we get stuck on a part that's not available, although 2N702 are relatively available parts. That's not a problem. 100,000 stock, that's great. But we are not dependent on one part not available or on having too many reels on the pick and place machine. So I will stick for it first with that kind of arrangement. Yep, that doesn't make sense. It doesn't make sense at all. And we will add a resistor to change the current. So we can put all of this a little bit deeper and deeper. Okay. So. So we can change the value of the, we can use the PNP switch. So, and we need to change that. That is one reason we would need to change this would be that the capacitance of the MOSFETs themselves is too high. I don't have the calculation formula in my head right now, so I will not research this on stream. But that could be a problem, that the capacitance of our MOSFETs is too high, or the gate capacitance, and we will not be able to drive the data with the required frequency and slope. So that could be a real problem. That forces us to use other MOSFETs. So we will first of all delete it and then add to a new net, and that would be LED data. LED data channel 1. So, and in this circuit we would be able to switch between the use of 5V LEDs and the use of 12V analog LEDs, 5V analog LEDs and 5V digital LEDs. So my first step, if we want simply 12V RGB LEDs, following will happen. Our V plus will be 12V, and on all the ports here I will use all these ports as the switching for ground, and that one will be turned off, so no problem. For 5V, we'll have 5V at this LED. We'll have the different colors down here, and then we're switching it. Like a 12V LEDs, no problem. For the 5V digital LEDs, we'll have 5V over here. We'll have our ground path will be these two, will be this, no, what did I choose? Oh, yeah, will be the red LED, red. So typically red LED will be ground, so all the current that flows in V plus will flow out at LED are ground. And this transistor Q6, or this arrangement, will give the 12V, the 5V signal, the 5V digital signal to the LEDs, so we will be able to connect our RGB, our VS1228B LEDs. That was right, wasn't it? Probably it was. Okay, that looks great. So that will be the first draft of our... Oh, I should change the... I should change the screen, I always forget this. So that will be the first draft of our current circuit. After we have filled in all the voltages and stepped about the whole circuit, we simply duplicate it times 3. And, or first of all, add all the components that we actually want to use and replace those. And then we'll be able to duplicate it times 3, and then we're happy. So, first of all, that's great. Let's do another sheet. That will be our power circuitry. It will be our LED driver. Nicht divert. LED driver. Let's continue with designing our front panel. And we'll add our digital circuit. Or control circuit. So what I like to do, I always divide my my schematics in 3 different parts, so I don't have problems with having schematics that are too big. And it allows us, or it allows me, what I like to do, and I didn't done until now, is to add some kind of schematic, or to add some kind of, let's take some R4. I expected now some sort of overlay. Let's try it again. I want to have R4 Q. Current sheet, all sheets. Okay. Why don't I get V? Am I completely off? No, I'm not. That is now. Okay, normally it should be now display sheet. Ah, now we get it. Usually I like to use some sort of print. I design my circuits so they are printable. The nice thing is if you can print them, everything looks better. Let's try it. I don't like this one. I want to see display titles. Ah, now we get everything. So we will probably will make it a little bit smaller, or we could do it right now. So it fits inside an A4 page. I don't have an A4 printer, so I will simply use A4. A4 is great. Can we use A4? Because if you take a look at the norms, you normally don't. You're not allowed to use A4 as an... When we do A3, I will get access to one. So, yeah. Now I can print it in. And after we're ready, we'll simply add those. Yeah. Great. Because if you can print them, it's something nice to show. And there's something non-digital, which is also very pleasing. So yeah, that's great. Then, front panel. Okay, for front panel, we will take a look on our bookmarked. Let's change it. C2 starting to. Also, for front panel, we'll take a look on our bookmarked parts, and we'll put them directly in. I will pop up the switches to add them later and the LEDs. I will I'll put them in directly. So we did some bookmarks, if I remember correctly. Bookmarks. I know. That was the potentiometer that we wanted to use. Please don't be there. Don't let there be please don't let there be 2 potentiometers. That would be so. Show bookmarks on 2. Thank you. That's easy. So. Okay, we have 2 potentiometers. That is very unfortunate, so we have to find out which one we wanted to use. Yes. Then we have that very LED series we wanted to use. So we can put in the footprint. That is great. And we have some... That was the switch we decided to use, yes. One thing I want to check, if I get them here, is do we get standoffs? Does LCSC provide standoffs and how much do they cost? That's something I wanted to know for another project. So why don't check it now, mechanical. Electromechanical devices, but we only want to have mechanical devices. Ah, here. Okay. Snow. No. No. Bolts. Here were bolts on screws, on studs. I have no idea with the English. Well, it should be standoff. We will find here standoff, or we don't. More screws. What are studs? Oh yeah, these look studs correctly. Nickel plated. Okay, we don't choose nickel plated. And for example, 10 millimeters. How much do they cost? Of course, I'm free. Okay, so the selection is first of all very small because only oh, the filter is not very good. That's unfortunate. 2 cents, but they're not passive. Oh yeah, they look pretty crappy. So even the display image looks not very good. Okay, they don't have so many stats. That's interesting. Okay, that's what I wanted to take a look at. We didn't bookmark our switches, didn't we? No, we didn't. That's okay. Then we need to go through our history. Of course, history is always something you want to. Your browser history is always something you want to show people. So, let's take a look. Rotary encoders. That could be our... Yeah, that will be our switch. That will have a right length, so or so. I have an easy ADA model. Let's take a look. Can we use this? Free trial. Oh no. They want to have a free trial for easy ADA. Well, it's a 6x6 switch. That should be a very generic part. So we do some component editing. So let's look here. We will want to do some components. Here, get trace. Component editor. So we will take a look on. We'll take a look on switches. I'm relatively confident that we will have here some sort of switch that will look exactly like our model. So at least that looks good. I'm gonna say this will be. Let's take a look. That will be in UAND with a part number, a non-JLC part number. here. That will be an TS. Oh yeah, of course. I have dip trace once in the VM, so I have to tip it like that. 5 KD slash A19B3 minus D2 A19B3 minus B2. Okay, that's okay. It's from UND. Switch, yes. And I don't know, will I? No, we won't have, we don't think we have this, and I don't think we have this. And we will add the unique name. And we'll add part numbers, so we have less problems with ordering, and everything. CS 2834860. Okay. Library save as. I don't want to save it as a library. I want to save it simply in another library. Also, I hope I can save it in another library. Oh, no, I can't. Okay. Nah. Okay. Like that. Insert. Come. Dude, come on. No, I can't go out, can't I? No, I can. Good. No. Okay, we'll... So we'll do this again. Components, switches. Switches. Key switch. Do I want to use key switch, or what kind of part is that? Ah, that was not very systematic. Let's say Gluck D6C000. DC6 00 F1 LFS. That's not the one I want to use. So besides, I'm checking if it's the right switch. That won't be now. I want to. Nope. Nope. Look, that could be on B3F 105. Yep, that could be okay. There 6x6 switches. We'll later replace the LED model. 6x6, yeah, that's okay. We'll use this one. Insert. And do everything again. That will be an VNTS 1095 KD A19 B3D2. UND. That is not interesting. That is definitely a unique name. Part number, won't have that most probably. We don't. And that's a TC28 24 860. Okay, right. Oh no. So that's everything. We could check the footprint if that's fits. One pattern. Nope, I want it to be pattern editor. Okay. So our libraries. Oh yeah, now I have to do another. Why don't have I my TSP here? Oh no, I don't have my TSP here because I used an already existing pattern. Let's check if we can do the same thing here, pattern. Of course, that would be the most easiest. Pattern description. Check pattern dimensions. Okay, let's see if the holes line up correctly with the datasheet. We need to have a 1 millimeter hole. That correctly, 1 millimeter hole. That's of course one of the better datasheets I will show you. We have diameter 0.0000 hole. Yeah, that's great. That's something you can work with. And okay, I want to have everything in millimeter. That are no, we can't use this pattern. That's 4.5, 4.5. Oh, wait a minute. We have a distance of. So we need to check that we have a pin pitch of 4.5 millimeters. That's important, I think, on both sides. And if you check this in dip trace, we will see that are not 4.5 millimeters. So we need to choose another pattern. It should be under switch or an S somewhere. Cap connector. Switches. Push button. I think under tactile. Let's try tactile. Okay. Oh yeah, that looks good. And let's search for something which looks bigger. That looks smaller. I think that's the one we just had, wasn't it? No, that is not correct. Let's search further. I would be really stunned if there was no 6x6 millimeter switch pattern here. Could that fit? The 1 millimeter holes are okay. Oh no, I don't get an. Oof. So even I have the bad impression that I'm not able to measure them correctly, because we only get no, that are 4.5 millimeters. That's okay. Of course, that's only the relative coordinates. The only relative coordinates and not absolute ones. 3.5, 6.5 and 4.5 millimeters. So that's actually, that fits. That will fit, yes. Okay, alright, pins connected. That will be, of course, important if we believe the datasheet. This will be pin 1. This will be so both on the long side are connected if we believe the datasheet. If we believe that, it should be connected like that. We will definitely need to check this. Double check this, or write it down. Okay, let's change this here. Okay, good. We'll definitely need to double check that pin out. But first of all, we're good. Yeah, we should be good. First of all, we're definitely good, because that seems to fit. Okay. Safe. Okay, front panel. Let's start by adding some switches. So, I will take a look on what we've wrote down to have on switches, and of course I don't have this document. So I thought it were 7 switches. Put them directly in the right orientation. So we'll have some kind of on-off switch, we have a channel select or RGB select, some RGB and channel toggle, some I don't know, some effect and something else. I think we did thorough thoughts about that. Should be enough. Then the LEDs. Yeah, we want to add some LEDs. We'll do this right now, and after that we will stop the stream. Yes, we will stop the stream after that. So, let's go back and check what kind of LEDs we've had. So we decided on using that kind of LED series, and we will add all of them. So, why is it untitled now? Ah yes, here. So we'll add a new component. First of all, let's check if it's available. If you need to do it, maybe it's already available in DipTrace, that would be very easy. search area or libraries. We want to have an LTST C90, C390. And of course I didn't change the screen again. So LTST C9030 GKT. If we have this. Of course I would need to search all of my libraries, but otherwise I would have to choose it. Because you're only searching for one part, it's okay. But that doesn't look good. Is the series available? Let's check again. Maybe only a few LEDs of its series are actually built in, so we would only need to add some. It would be of course the easier way, but I imagine we don't have that luxury. Nope. So we are able to put it in by hand. We'll do this right now. So we want to have an LED as a template. We need to have A and K. So second LED template. I will take the first LED template, that looks better. And we will have an LTST C9030 GKT. Manufacturer light on. And we will add an unique name. I don't know how should be. We will add an JL. We will add a part number. CSC part number. Before I edit, I want to check in a second window how it's named. Okay, we'll get components, and we want to have some sort of capacitor or switch. Let's take a switch example again. So tactile. And let's check. I wrote it like that, and we will do it also. So that if we export everything, it will be more uniform, and if it's more uniform, everything is better. I opened the pattern editor, didn't I? Ah, here. Okay. Use unique name. It's and that will be C36565. Okay. And add unique name. We'll do this too. Put in the part number. It will be LDST/C9030 GKT. No LTST, yeah. Yeah, but very unfortunate that they didn't added the additional fields into the pattern, into the templates. They should do this. Alright then. Write in the forum, maybe we will answer and add those in the next version. That would be great. Okay, then let's check for a pattern. If we take a look, kind of size we have. So we'll most probably have some sort of LED pattern here. Switch to LED chip. Great, and we want to have 055, 320, 42. So we have no standard LED. But for 23, let's check look if we have one available. $80mm. We have a body length of 320 or 3.2 millimeters. Let's take a look if we have this available. So it's a relatively big LED actually. 2mm body. There, take a look. Yeah, it has 2.4 millimeters width. That's a really big. But these footprints look pretty good. Okay, this is a little bit bigger. Let's take a look. 310 for 240. Get this one. 320. So okay, we will not add the pattern yet because the right pattern is not available in here. We have a pattern which is a little bit oh no, that's the right one. 320, 24. Yeah. How big are those? They're a little bit big, but that's not a problem. We can use those. Okay. Cathode mask. So the cathode is masked here, and the anode is masked. No, the cathode is. So that should be correct. Cathode is pad 2 with the mark. Yes, okay, great. Let's add that one. What's the recommended? Let's check. Okay, the suggested soldering pad dimensions are vastly different, so we need to rehearse this definitely. Let's take a look. If we compare those, we'll find that the solder pad dimensions that are suggested are completely different than the ones we have ready to use in our library. So we will change them, definitely. Although it most probably will not make such a big difference, I would change them a little bit. Especially for hand soldering. This one will be great because it's relatively big, but for use in an automated system, you want to use the provided one. Okay, that's great. We'll save this. So now we can add all of the other ones. But that's the point where I would finish for today. Take a last drink of coffee. Okay, that will be all for today. We will. We definitely did great progress today. Added some footprints and prepared everything to do the front panel circuit the next day, or the next to do the front panel circuitry next week, and finish that part of the project. That's great. See you, goodbye.